This video will be on the x and y intercepts portion of the 5.4 note packet. X and y intercepts, we've studied them before. We know the x-intercept is where a graph crosses the x-axis. The y value here is always 0. If you don't remember, sketch a graph and think about it. So here's a linear equation, but it's the same idea with rational equations. The x-intercept, where you cross the x-axis, the coordinates there are always x, 0. The y value there is 0. For the y-intercept, it's the point where the graph crosses the y-axis, and the coordinates there are always 0, y, whatever your y value is. So the key for the y-intercept is that x is always 0. So, given this example, y equals 3x plus 4, we can find the x-intercept by setting y equal to 0. So we have y equals 3x plus 4, set y equal to 0, and solve. So I'm going to move 4 first. So I have negative 4 equals 3x, and x equals negative 4/3. Alright, that was our x-intercept. Let's do the y-intercept. The y-intercept, you always set x equal to 0. So our equation was y equals 3x plus 4. Set x equal to 0. 3 times 0 plus 4. Well, 3 times 0 is just 0, so that goes away. We just have y equals 4. Coordinates here would be 0, 4. That's this point over here. And that makes sense because when we look at our original function, we know 4 is the b value, and the b value is always the y-intercept. Our coordinates for the x-intercept are negative 4/3, 0. And that's right here. Alright, so let's apply this idea to rational functions. In example 4, there's actually a typo. This negative 2 should actually be a positive 2. So change that to a positive 2, so plus 2. And it should also be plus 2 in example 5. Okay, so we're going to find the x and y intercepts without factoring first, and then we'll think about it with factoring. When I go to do the x-intercept, we said that my y value needs to be 0. Okay, so 0 for y equals x plus 3 over x squared minus 3x plus 2. Well, to solve, I need to get rid of my denominator here. How do I get rid of the denominator? I'm going to multiply to both sides. I'm going to multiply it to the left side, and I'm going to multiply it on the right side. Okay, what's 0 times x squared minus 3x plus 2? It's just 0. And then on the right-hand side, we have x plus 3 over x squared minus 3x plus 2 times 3x minus 2x plus 2. These cancel, leaving me with just x plus 3. Okay, if 0 equals x plus 3, x equals negative 3. That's my x-intercept. So my x-intercept was x equals negative 3. Let's imagine that we had done that with factoring. So I'm going to erase this, use this space again. Hopefully you're able to write a little smaller than I am on this iPad and can fit it in this space without erasing. Okay, so let's say I had f of x and I factored it. F of x factors to be x plus 3 over x minus 2, x minus 1. Because if you think of the diamond, you've got positive 2 in the numerator, in the a times c value, and negative 3. Oh, let's see if we can fit this over here. Okay, we have 2 as the a times c value, negative 3 as the b value, negative 2 and negative 1 make the diamond work. Okay, so that's the factoring. If I'm still solving for the x-intercept, I can do 0 equals, actually, let's do it over here. 0 equals x plus 3 over x minus 2 times x minus 1. If I'm trying to solve for x, I'm going to multiply x minus 2 and x minus 1 to the left side, and to the right side here, x minus 2 times x minus 1. Oops, a little squeezed for space. Okay, it cancels out here, and on this side, I just end up with 0, because 0 times x minus 2 times x minus 1 is just 0. 0 equals x plus 3. So x equals negative 3. All right, so factoring didn't help us here, but it also didn't hurt. Let's take a look at y-intercepts. Just clear this. Okay, for y-intercepts, our x value, our x value needs to be 0. Okay, so I can just plug 0 into this equation. In the numerator, I have 0 plus 3 over 0 squared minus 3 times 0 plus 2. That gives me 3 over 2. And I'm done. My y-intercept was just 3 over 2. Okay. Let's see what happens if I factor my function and then find the y-intercept. Okay, so my factored function was x plus 3 over x minus 2, x minus 1. Plug in 0, you get 3 over negative 2 times negative 1, which is 3 over 2. So if your function is factored, it can make your y-intercept a little faster because it's easy to do 0 plus 3 mentally, and 0 minus 2, and 0 minus 1. Okay, so one other key point I want to make. When you are doing x-intercepts, so I'm actually going to backtrack for a second. When we had x-intercepts, and you had 0 equals, actually let me write it in the center. You had 0 equals x plus 3 over x minus 2, x minus 1. We said we were going to multiply it by the denominator. And that's true every time. And then the denominator always cancels. And over here, anything times 0 is 0. So this always just becomes 0. So a shortcut for finding the x-intercept is to just use the numerator. The denominator will always cancel out. So you can go straight to the numerator and say 0 equals the numerator and solve for the x-intercept. So the shortcut for this is the x-intercept is to set the numerator equal to 0. If you don't, that's fine. You can still get the same answer. This just saves you time. Okay, on to our next example. X and y intercepts. Let's do the x-intercept first. And we're actually going to use the shortcut we just talked about. So we can set the numerator equal to 0. So 0 equals 3. Except, wait a second, 0 can't equal 3. So what does that mean for my x-intercept? It means there's no x-intercept. As simple as that. Okay, let's talk about the y-intercept. For the y-intercept, we are going to set x equal to 0 and plug it in. All right, so let's look at the factored version first. F of x equals 3 over x minus 2 times x minus 1. Oops. If I substitute 0 in there, just like before, I get 3 over negative 2 times negative 1. This is 3 over 2. So my y-intercept is at 0, comma 3 over 2. All right, so let's summarize this. To find the x-intercept, set y equal to 0, and the shortcut just set your numerator equal to 0. All right, the y-intercept, set x equal to 0. That's it. Okay, so time to practice. You've got 2 examples below. You can check your answers on the key online. And that's it for now.